All right. Hello, everybody. Ooh, feeling pumped. Let's do this. My name is Marco Gorelli from Quansight Labs, and I'm here to talk to you about polars and time series. We'll talk about what it can do, what it can't yet do, and what you can do about it. At Quansight Labs, I work a bit on polars, pandas, narwhals, data frame related things, consulting, training, and today, super excited to be speaking here for you at this repos event with Open Teams. Now, I recently gave a talk on polars and time series in Germany, and it was my first time there, so I figured I should learn a bit about German culture to prepare. And there's one bit about German culture which really struck me, which I thought I would share with people before starting the presentation, and that is the art of lüften. Now, to anyone outside of Germany, it might look like it's just the German word for ventilation. But no. Germans are absolutely obsessed with this. They will ventilate their room multiple times a day for at least 5 minutes, regardless of whether it's the middle of summer or whether it's the middle of winter in the coldest part of the Bavarian Alps. They're going to get their lüften. I hope that you're all in adequately lüfted places listening to this at home, so we can all maintain concentration while we talk about polars and time series. The way today is going to work is I'm going to start by giving you a super fast crash course on polars. Make sure we're all up to speed. Then, after these 5 minutes are up and we are all expert polars users, we can talk about the built-in polars time series methods. We'll then talk a bit about how to go beyond polars. We'll see how I feel in that moment. Maybe I'll do some live coding, maybe I won't. And then we can talk about what comes next. Right, hope we're all feeling pumped. So let's do this. Why should we care about polars? Polars is a data frame library originally started in 2020, and it's been gaining a lot of traction, especially in the last year or so. We saw G Research, a quantitative research firm based in London, talk about how for them, polars isn't just an improvement, it's a game changer. Their words, not mine. We saw SkyMax post enthusiastically about how they're using polars and on several tasks are recording 10 times shorter processing times. Czech Technologies, which is a Dutch startup, they talk about saving on their cloud expenses using polars. And more recently, NVIDIA, their Rapids team, thought that polars was significant enough that they should contribute a GPU engine to it. More on this coming soon on the polars blog. Make sure to subscribe there if you want to be the first to hear about it and tell all your friends. Now that we're all feeling hyped about polars, let's talk a bit about how to use it. Now, the fundamental data structure in polars is called the data frame, which is a collection of columns, and each column has a data type. And each element within that column has to have the same data type. And the way we interact with these data frames is a bit different to how you might be used to manipulating data frames in pandas. We use something called expressions. Now, expressions, they're a little bit complicated to understand. So before we talk about expressions, let's talk about data types. Now, if I give in-person presentations, I usually ask people to give me a cheer when they hear their favorite data type called out, and I think today should be no different. I won't be able to hear you, but I'll read out some data types, and if when you hear your favorite one, you give a cheer, then believe me, I'll just know that you cheered. So we've got numeric data types, we've got booleans, strings, very efficient strings, a categorical data type, nested data types such as lists, structs, and arrays, and finally, the data type that we are all here to celebrate today, temporal data types, in which we have date times, dates, durations, and time. Right, now that we've got data types out of the way, let's talk about expressions. An expression is, formally speaking, a function from a data frame to a series of columns. For example, pl.call a times 2.alias b means, given some data frame, take column A, double it, and rename it to b. Now, an expression, being a bit like a function, doesn't actually have a value. It only assumes a value once we evaluate it in the context of a data frame. A bit like the function given x double x doesn't actually have a value until we give it a concrete value for x. So let's take a look at how that works. If we start with a beautiful data frame like the one presented above, then we can create a new data frame with an extra column given by the expression we just defined. I think most people see this and very quickly gain an intuition for how Polars expressions work, even though they might not have a formal definition to work with. Let's look at another example. We can use common arithmetic and comparison operators with expressions. So we could make a Boolean column which indicates where some given column is greater than 1. And if we then filter using that expression, we can determine which rows to keep in a data frame. Magic stuff. Now that we're all Polars experts, let's talk specifically about Polars and time series. Let's take things up a level. And as an example dataset, I'm going to use a dataset which I found on Google BigQuery, which records the Polars downloads for the past year. And it shows 3 columns: number of downloads, date, and source, as in where was it downloaded from. Now, I recognize some of these, like pip, but I have no idea what some of the others are. Like, well, I'm not going to name any of them to not risk disrespecting them, but I don't recognize most of these names. Let's leave it at that. So personally, if I want to record Polars downloads over time, I'm more interested in aggregating these per day and know what the total number of downloads per day was than in dividing it through into channels. So let's talk about how to do that with Polars. Perhaps first a little caveat on these numbers. I'm not entirely sure how accurate the BigQuery stats for downloads are, but if we plot them, then we see a line that goes up and it looks pretty. So that's good enough of a reason for me to use it. The first thing we're going to want to do is we're going to want to parse our data. Now, the world runs on CSVs, so of course I downloaded the data as a CSV file, and I'm here to show you how to process it. Now, life-changing tip. When you're reading a CSV using Polars, use try parse dates equals true, and then Polars will try to guess the datetime format, and if it can, it'll parse it using that format. This is much more convenient than having to type date format equals YMD by hand. Saves you a lot of precious time. It's not just about saving time, though. It's also more efficient to directly read it in as a date than to read it in as a string and then convert it. Anyway, once we've read our data in, we need to aggregate it. And the way we do aggregations in Polars is within a group by, we specify an aggregation using expressions. And this is maybe a bit different to what Pandas users are used to. So before we get any further with time series, plotting, grouping by date, let's go on a little detour. Let's go on a groupby.ag detour, and let's talk about how that works. I'm going to start with a friendly comparison of Pandas and Polars syntaxes. This comparison is going to stay friendly. We're not going to compare performance or anything. It's just syntax. So I think both of them are pretty clean at expressing the query, find the mean of column B for each group A. Both pretty good. I like them. If we ramp it up a bit, find the maximum value of C where B was greater than its mean per group A, then all of a sudden, this is where we see that expressions really shine. Because in the Polars syntax, I can just do group by ag, and then I put up an expression which expresses the aggregation I'm trying to solve. But in Pandas, I can't do that. I need to either use apply and a Python lambda, and if there's one thing you remember from this talk, I'd suggest it be that anytime you find yourself using apply and lambda, whether in Pandas or Polars, it's probably a pretty good sign that you're shooting yourself in the foot. Or we could pre-compute B's mean per group and then do 2 group bys. Or we could do other messing around with internals. It's complicated. Like, I'm not saying it can't be done, but I am saying in Polars it's pretty clean. And this is probably why it's a fairly common refrain among Polars enthusiasts to say, I came for the speed, but I stayed for the syntax. Indeed, express yourself is probably one area on which Polars and Dr. Dre agree. Right, now that we've exhausted talking about Polars group by aggregations for a bit, let's talk about smoothing. Let's get back to time series. After all, that's probably why we're all here today. And let's go back to looking at the daily downloads for the past year. I like the fact that it's kind of trending up, but this looks really jagged to me. Yeah, it's kind of hard to see what the general trend is. So let's see if we can smooth it out a bit. And one way to smooth it out is by using a rolling mean, which does what it says on the tin. You replace each value with the average of the last X days. If X is big, then the overall curve will be more smooth, and if it's small, then it'll be closer to the original and more jagged. And the way we do a rolling mean in Polars is by using the expression rolling mean by. If you don't like expressions, then Polars might not be the best library for you. I'm also going to call out a bit of attention to the fact that to make this plot, we just did .plot.line. Yes, that's right, Polars does have a native plotting namespace. So if you happened to read some old blog posts about how Polars doesn't do plotting, well, those are exactly what I call them, old, outdated blog posts. They might be good in other regards, but the fact that Polars does not work with visualization libraries is empirically disproven in September 2024. Now, the thing with rolling means is that they weight every point the same way, and that's not something that is necessarily intuitive, is it? Like, you kind of maybe would prefer that more recent points be weighted more than older points. And one way to do that is by using an exponentially weighted moving average. There's a little bit of a scary looking formula in the Polars docs, but if you work through it with pen and paper, it's not nearly as bad as it first seems. It basically tells you give more weight to recent points, and as you get further away from the current point, you weight each point less. The way we do this with the Polars API is EWM mean by. Again, expressions everywhere. What else have we got in Polars? If you're working with business days, we've got you covered, including custom weekdays and custom holidays. So regardless of whether you're working just within your own country or with colleagues who celebrate different holidays, who have different weekends, there's functionality for doing that. We can do upsampling. So that is going from, let's say, data that's every 2 days to data that's every day. And then you can specify some interpolation strategy to fill in the missing values. Polars also supports downsampling, which is kind of like Pandas resample. All operations can be done in a time zone aware manner. And I'm going to take a chance to plug my PyData Eindhoven talk, Polars and time zones, everything you need to know. You can also offset by durations. You can do rolling aggregations. And for anything that's a bit too niche for Polars, there's a plugin called Polars XDT. The X stands for extra, and DT stands for date times. And finally, for anyone who's interested in gazing into crystal balls, also known as forecasting, Polars is supported by major forecasting libraries such as StatsForecast and FuncTime. Cool stuff. But what about when Polars isn't enough? I recently saw this Stack Overflow question. Somebody was asking about how to do a very custom kind of cumulative sum. They don't just want to accumulate the sum, but when the cumulative sum goes above a threshold of 5, they want the cumulative sum to reset to the current value. Now, just in case it's not clear, let's just go through an example. People often learn better from examples than by highly accurate descriptions. So let's do an example. In this case, we're starting with 1, 2, 2. So the cumulative sum is 1, 3, 5. Just keep adding the number you encounter. At this point, 5 is if we add 2, we would go above the threshold of 5. So for the next value, we need to reset it to the current value. And then we've got a 2 plus 1 is 3, but 3 plus 3 is 6. So again, that's above the threshold. So we need to again reset it, and so on. How do we do this in polars? Now, I tried to do, well, the person asking on Stack Overflow they said that they tried to use a Kyung sum, but that doesn't quite work for this. Doing modulo 5 is also not really a solution. Try if you don't believe me. So what can we do? This is the kind of very customized operation which data frame libraries typically don't have built in. So we need a workaround. And the way that a lot of people will find is something like this. You iterate over your rows in Python, and you construct your result as you go. Now, this is technically correct, which is the best kind of correct. However, anyone who's tried it will know that it's a bit slow. Can we do better? And yes, we can. We can write a polars plugin. All you need to do is follow the following 6 steps. So first, I recommend using Cookie Cutter, which gives you a template that you can start your plugins from. Then you'll need to install Polars and Maturin. Maturin is what we use to build and publish mixed Python and Rust packages. And Polars, well, we're not going to get very far with writing a Polars plugin without Polars. Then comes the hard part, which is to write a Rust function. But my claim is that this is less hard than you're thinking. Finally, you need to register the Rust function in Python, compile, and congratulations, you have a plugin. Now, the last time I gave this talk live, I claimed that it's possible to live code it in 5 minutes, and did it. Now, we are a little bit short on time today, so maybe I'll skip the live coding, but I will show you the backup slides, and we can take a look there at how this works. So first of all, I've got a tutorial online called How You, Yes, You, Can Write a Polars Plugin. That will take you through the prerequisites, all the Rust you need to know. Let's say the barely enough Rust that you need to learn in order to extend Polars expressions with your own plugins. And then we cover various common scenarios, including how to publish your plugin to PyPI so that other people can use it, and lots of extra assorted items. Now, the way that you would define this plugin in Rust would be to write something very similar to how we would have written it in Python earlier. The difference is we are now working directly on the chunked arrays which are behind series rather than just iterating over Python elements. When I showed this in Berlin, people generally commented that it looked a lot easier than they were expecting. And indeed, that's my claim with Polars plugins. You only need to learn the basics of Rust. You then need to learn a bit about how things fit together. But then you can probably solve maybe 99% of your inefficient map elements / apply usages. On the Python side, the way it works is we just need to tell Python that it needs to look for a Rust function called cumulative_resetting_sum. The other thing we need to be careful about is saying isElementWise equals false. isElementWise tells Polars that it can apply certain optimizations, which it cannot in this case, because the cumulative resetting sum needs to consider the context of all rows in the column rather than just what's at the given row. And once you do that, you'll get a 10x speedup virtually for free, just by having written, 20 lines of code. If you work through the tutorial, this will be child's play to you. Now, in confusion, we've learned about a lot of things today, so let's conclude this talk by going over them again. We've learned that Polars is a data frame library gaining a lot of traction, and that many data science libraries are adding native Polars support. Polars has excellent support for time series analysis, and you can extend Polars with plugins. So what comes next? I hope that we can introduce better ergonomics, especially in rolling functions. Like, it's good for some things are a bit less convenient to write. So let's make things better. Let's make things more user-friendly. I hope that we can have more exponentially weighted moving windows, rather than just mean, sum, and variance. And in particular, that more of these exponentially weighted moving windows can be done in a time-aware manner. I'd like to add expanding windows, but this is a bit of a big task. And this is a good time to mention repos, which is a project which allows you to empower open source projects. If you can look on repos, find projects that interest you, and see if this would benefit your company, and if so, see if you are able to sponsor it. This will then benefit not only you, but the entire community. Finally, I'm hoping that Polar's plugins can be made easier and more accessible to write, so that everybody can benefit from this magic. And this could be you. Somebody in the Polar's Discord recently was talking about how they finished implementing Polar's plugin, and it took their daily pipeline down from 45 minutes down to just 5 minutes. They say that they loved Polar's before plugins, but now it is easily the #1 most important tool in their data stack. Thank you, thank you. Well, it's certainly pleasant to read these things as a library maintainer, given that a lot of users aren't exactly polite in their complaints. So thank you to this person who wrote this. Thank you for attending. It's certainly good if you're able to write a Polar's plugin, and if you're also able to take things down from 45 minutes to less than 5 minutes. It's good if things take less than 5 minutes. Generally speaking, it's not true if you're in Germany and you're trying to get some Luften. Right, thank you everybody. Now please go out and use the Polar's API. I've been Marco. Have a great rest of your session.
Thank you, Marco. What a great tutorial. Hi, everyone. My name is Inessa Pawson. I'm the Open Source Program Manager at OpenTeams, and in this role, I lead initiatives focused on widening the contributor pipeline and bringing funding to more open source projects. And today, I'd like to share about the REPOS program, short for Reimbursed Enhancement Proposals for Open Source. These days, every organization, every sector, corporate, government, academia, nonprofit rely on open source. However, there are still very few funding models that allow an organization from any sector to pay maintainers directly. The OpenTeams team collectively holds unique expertise on all things open source, from software architecture, governance, and contributor experience to legal advice, recruitment, marketing, and accounting. Building on this expertise, we created Repos, a funding platform that connects open source developers with sponsors and contributors. Whether you want to support open source developers or you have an idea for an open source project, we are here to support you. So how does the Repos program work? Any Repos partner, open source contributors, maintainers, and organizations can submit their open source enhancement proposals on the Repos website, repos.openteams.com. OpenTeams promotes your proposal to our network. We connect you with the contributors who can work on the deliverables and sponsors who are interested in funding your proposal. Once all the key partners of the proposal are identified, OpenTeams provides support in reimbursement funding management, reporting, partner communication, and other aspects of project management while you focus on deliverables. If you are an active open source contributor or maintainer, Repos is a great way to secure funding for your open source work. You don't have to do academic research. You don't have to be affiliated with an academic institution. You don't even have to do networking at conferences and dinner parties. Repos gives visibility to your project and your open source contributions, allowing you to connect with a broader network of sponsors and collaborators. Repos also provides support so your dev team can focus on developing the open source project. If you're an organization looking for the ways to engage with open source projects, Repos allows you to invest directly in cutting-edge technology, get the specific help and improvements that help your organization to succeed. Directly support the open source software and the communities that your business depends on. If Repos funding model piqued your interest, if you're interested in funding Marco's proposal for Polars, please reach out to us on repos@openteams.com. If you have an idea for an enhancement proposal, please submit it directly to the website. And if you have any questions, comments, suggestions, please reach out to me directly at ipawson@openteams.com.